I don't know.
Like never coming back.
She's just stuck down there forever.
Honestly.
Okay. So in the little box, we're gonna write a little paragraph because not a little paragraph. It's a sentence. So for a triangle inequality theorem, basically, we're gonna say that the sum of the two smaller sides need to be larger than the third to create a triangle. So yeah. So the sum. What's sum mean? Yeah, addition, the answer to an addition problem. So the sum of the two smaller sides need to be larger than the third side to form a triangle. I'm going to get lazy at the end. I'm literally going to put a triangle. So the sum of the two sides, the two smaller sides, need to be larger than the third side to form a triangle. So this is very easy today because all we're doing is adding numbers to see if the two smaller sides add to be larger than the third. If they're larger than the third, then it forms a triangle. So we're going to say yes. If it's less than, then we're going to say no because it has to be larger than. So for numero uno, what are the two smaller numbers? 8 and 17. If you take 8 and 17 and we add them together, I'm going to show the math just for the first one. But I'm taking the two smaller numbers, I add them together. How much do I get? Okay. We get 25. Is 25 more than 24? Yes, it is. So that means that those three numbers would form a triangle together. For number 3, let's go straight down. So if I go straight down, my two smallest sides are what? 12 and 25. If I take 12, I add 25. How much does that make? 37. Is that larger than the third side? Yes. Okay.
Exterior. Wait, do I have to write out all the numbers?
No. So literally, we're just going to use a calculator. So at this point, now that we did 2 examples, let's just use a calculator. So number 5, take a second in your calculator, add your two smaller sides together. What do you get?
40. 50.
You get 50. Is 50 greater than 50?
No.
No, it is equal to. So we're going to say no, because it does not form a triangle, because it has to be greater than. So take a second. Try the remainder, like 7, 2, 4, 6, 8. Try the rest of those sections. You can literally just use a calculator and write yes or no. You're adding the two smallest sides together. If the two smallest sides added together is greater than the third side, then it forms a triangle. Easy peasy. Do I eat lemons? I mean, I'll put like lemons in my food. Like,
Look at number 2. It says
like
20 greater than 7.
What's all good?
I don't know. My husband's on a carnivore diet right now, so we just have chicken and eggs every night for dinner, which is great because it's like takes me like 10 minutes to cook. I'm just like, and I'm like, here's your healthy meal, and I'm gonna eat the same thing because I don't want to cook more than I have to.
Very much blood.
He's like, I don't know. He's like, what is he doing right now? He's cutting. He's cutting.
Oh yeah.
Just got out of his bulk. He says I'm like his biggest hater because all I do is make fun of him. And he's like, and I'm like, be quiet. Okay, 7. If you add the two smallest sides together, and what do you get? Well, I don't even know if you like wrote it down. Is this a yes or a no? This is a no. Okay, good. For 2, if you take the two small sides, that's 6. The largest side is 7, so 6, 7. So is that larger? No, it's not. Okay, what about 4?
Yes.
Yes. What about the next one?
Yes.
Yes.
Yeah.
Next. Yes. So, that was easy. Great. Let's move on. So the next thing, and the reason why, I don't know if you care, the reason why this theorem is like an actual thing is because if you have two sides that are like, let's say this is like, I don't know, this length, and this is like this length. And then if I add these together, no matter what, to make a triangle, this is going to be shorter or less than, what do you call it? This and this like added together. So like if it was longer, it wouldn't form a triangle because then like the sides wouldn't match. Like this would not connect. That's why like this theorem exists, but it doesn't. Okay, so the next thing is we're going to write a range of possible scales. So basically a compound inequality from algebra 1. Compound inequality is where x is in the middle and you have two less than symbols and you had a smaller number and a bigger number and x was between these two numbers. It's called a compound inequality. It was like your ands and your ors. Does that sound familiar? No, I don't know, whatever. And basically you have two numbers. So I'm going to put a little hashtag for like whatever number that is. And then put a little hashtag over here because whatever number that is. This is your smaller number and this is your bigger number. And basically x would have to fall between those two numbers. Huh? Well, you can't put any numbers. The numbers here and here, the smallest one is found from the difference. What is difference? Good. So this is difference. We're going to subtract. We're going to minus. The larger number is found by the sum, which is plus. So all we're going to do is write a range of possible answers for the side lengths. So if I were to find the difference, if I were to subtract these two numbers, what do I get? 8. And I'm put my little less than symbol, my x, and my less than symbol. To find the largest number, I'm going to add them. 36.
Oh.
What this means is the third side of the triangle would have to fall between 8 and 36, whether it was inches, feet, whatever you're talking about. So x, the number, the third side, would have to fall somewhere between 8 and 36, meaning 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, all the way up to 35. It cannot be equal to 8 and it cannot be equal to 36. So let's go straight down for 11. If I subtract these two numbers, what do I get? 8. And if I add them, what do I get? 14. So try 13 real quick. Use a calculator, don't hurt your brains. If you,
Okay. Oh,
some of you can't subtract, so
That's fine.
how much is it? If I okay, yeah. And if you add them, how much do you get? Okay, good. Adding is easier than subtracting. So 15, the next one says, if a triangle has the lengths 15 and 27, so those are my two sides, check all the possible lengths for the third side. So if I subtract 15 and 27, how much do I get? I get 12. And then if I add them, how much do I get? 42. So I'm going to choose all the numbers that fall between it. Does 34 fall between those two numbers? Heck yeah. Does 12? No, it doesn't, because 12, it's not or equal to. Remember that little line that would be underneath this? So 12 does not count. Does 29 count? Heck yeah. What about 18? Heck yeah. Does 43? No. Okay. So try 10, 12, 14, 16. Easy peasy. You're subtracting them. You're adding them. You're just writing the inequality. The last one, you're going to choose all the possible answers that fall between your inequality. So when you minus it and add it, just find all the numbers that are between it. Easy peasy. Oh, here's the brain. Yeah. So did you subtract them? You left with 6 and 7. Yeah, so you need all the numbers between 36 and 4. So it's 35 between it. No, it's 58.
I have one, but
47.
yes.
Yeah, and then before 700.
Don't worry.
That's it.
You really I'm got it.
Oh, literally.
So 45 minutes. From 30 minutes.
I remember you could have what's next.
This is absent.
You better do that. By the way. You got a feeling for a lot of it.
Okay, so 10, you should have 3 is less than X, which is less than 59. 12, you should have 26 is less than X, which is less than 64. 14, you should have 9 is less than X, which is less than 25. And there are 2 answers for the last one. What are they? 47 and 39. Easy peasy. So the next thing is also easy peasy. It's rearranging basically the smallest angle to largest angle, or the smallest side to the largest side. So rearranging in orders. Some of you have good eyeballs to where you can just look at the picture and tell which angle is the smallest, which like is common sense, and you should be able to just use your common sense. Some of you don't have common sense, so I'm going to show you the hard way. So the smallest angle is technically always opposite of the shortest side. So if you think about this, if I have a really, really small, acute, itsy bitsy teeny weeny angle, okay, that's going to create a side that's really short. So if I have a really, really tiny angle like this, really tiny angle, that's going to make a really small side. If I have a really big angle, that's going to create the side that's opposite to be longer. So based on the angle's width, that side, because then I can have like an obtuse angle. If I have a crazy obtuse angle, it's making a side to a triangle that's really large. So based on the angle, if the angle is really small, it's going to create a really small side. The larger the angle, the larger the side. So it's always opposite of it. The largest angle is always opposite of the longest side, just like I just showed you. So we are going to order these angles from least to greatest. So the smallest side is 7. What angle is that created by? A, because it's opposite of it. So A is the smallest. So we're going to say angle A. What side is the next shortest? C, because it's 10, which is opposite of C. And then the last one would have to be the largest, which is B, which opens up to make 12. We're going to do the same thing, but with the angles, writing out the sides, which is literally the same thing, just opposite. So the shortest side is always opposite of the smallest angle. The longest side is always opposite of the largest angle. So it's just like literally using common sense to work backwards. So the only thing is, in this picture, we're missing an angle. Does anybody remember how much a triangle adds to make? 180. So we don't have to write this in a calculator. If I subtract these 2 angles from 180, how much is my missing angle? What is it? 35. So we're going to write the shortest, least to greatest. We're going to write the shortest side first. So the shortest side, if you use your eyeballs, you should be able to tell which one's the smallest, okay? It's this side. The reason why is because it's opposite of 35. So we're going to say ED. So when you write an angle, you use 1 letter. When you write a side, it's 2 letters because it's talking about the distance between them. So what would be the next shortest side? DF, because it's opposite of 42, or if you have eyeballs, you can tell it's the next shortest side. So DF. And then the longest is obviously EF. And once again, you could write these letters backwards. It doesn't matter really the order of the letter itself. Normally it's in alphabetical order, but it doesn't matter. So we're going to do 1 and 2. We're going to skip 3 and 4. So we're going to order these from least to greatest. So these are angles. So which side is the smallest? 17. So what's the angle that's opposite of it? M. So M has to go first. What's the next shortest side? 20. What angle is opposite of it? P. And then next one, N. So try 2. The smallest side is across from the angle.
Wait, that's it?
Yep, that's it. All you're doing is ordering the angles from the greatest. So that's why it's like super fast.
What is so supposed to be now?
They're gonna be crazy.
Yeah, I'm not coming
Oh,
tomorrow.
that's Are you doing?
Yeah, like 18 tomorrow, bro. Oh,
Yeah, probably will.
yeah, since
It's like.
Oh,
It's for looking Yeah,
No, never feel all right.
because I teach all the Excel.
But yesterday we got, yeah, what's it?
Okay, so what's my smallest?
TRN.
T first, because it's opposite of 30. The next one would be R. Then it would be S.
Like I did nothing.
Okay, we're gonna do one more. We're gonna go down to number 5 and 6, or I guess like 2 more. We're gonna skip 7 and 8. So cross out 7 and 8. So we're gonna order the sides from least to greatest. So you have a missing angle, a triangle adds to make 180. So how much is that missing piece? Okay. 92. So we're going to order the sides from least to greatest. If you have eyeballs and you can tell which one's the smallest side, you can use your eyeballs. If you don't have eyeballs, you can use the math. 31 is the smallest angle, so it's opposite of the shortest side. Smallest angle, shortest side. So KL should be first. If you have eyeballs, you should be able to look at it and tell that's the smallest. What's the next smallest side? JK. Mathematically, because it's across from 57. 57 is the next smallest number, so that's the smallest side. The largest angle is across from the largest side, which is how much? JL. So try 6. Same thing. You're going to find your missing angle, subtracting from 180 because the triangle forms 180.
Wait, after we get the angle, what do we do?
Then you write out the shortest side from these two greatest.
What do you mean shorter? Like if you add both numbers.
But like the opposite angle is probably.
Wait, why is it two like better now? Like I don't
Because
know.
of the side.
So do we get the angle for the side? Oh, the side. Yeah. So how do we get? We just add both numbers like on that side, or how do we get it? Like 59 there will be TV.
Yeah, so the smallest angle goes into the smallest side.
So GT.
So 50 degrees is smaller. Opposite. So which one's my smallest side? ST. Because what's the next smallest side? SV. Last one is TV. So, these notes you are not taking a picture of. They are for your notebook because it's really easy for you to, okay. So your classwork paper, instead of making the paper double-sided like normal and you taking a picture of it, I just made them separate papers. So that way you can just turn in the classwork. So this paper is not hole punched. This one will be turned in, okay? So we're gonna do a couple to get going. This is a mix of yesterday and today's. So let's start with number 1. Number 1 says CD is parallel to something. What is CD parallel to? PN. So you just write PN. That's it. Let's go straight down to number 3. We're going to find missing side lengths. We have to find CD, which is a mid segment that is parallel to this line that's 16. So how much would CD be if the outside 16?
8.
8. That was easy. Let's go straight down to number 8. Number 8 has extra numbers in the picture to confuse your small brains. Yes. We need to find PQ. And with these extra numbers, you're looking at the parallel line. So you're not looking at these Taco side lengths. Who cares about those? We're looking at parallel. So this is 30. So we cut it in half because we're going in. So 15. Easy. Let's do one more together. Let's just go straight down to number 10. So number 10 has more than just numbers. It has equations.
This is what you like said me.
They're not equal because this one's short.
Oh, you gotta do it by
Yeah. Which one gets multiplied by 2?
the
The small interior one. So we're going to take the small piece. We're going to multiply it by 2 because they're not equal. They're half the length. So we're going to double it. And then we're going to equal it to what's on the outside. This is what we did yesterday, mid segments of triangles. So distributive property, I got to get rid of my parentheses. So I'm going to use multiplication to bring the 2 in. 2 times x is 2x. Plus 38 equals x plus 29.
right?
Now it's a normal solving problem. Do you want to minus 29 or minus 38? Let's do the 29 because it's smaller. Hopefully not have negative. So I'm going to minus 29. Close, but not close enough. It's not 9. Yeah, it's negative 9. So in this case, I'm going to minus 2x, which is going to throw off your small brains because it has a negative. Wait, is it negative? No, this is positive. I'm crazy. But in the end, it ends up negative. So this is 9 equals negative 1x. And, oh, crap. And you have to divide by negative 1 to get rid of the negative with the x. So in this case, this is the only negative. That's why I wanted to do it together. So x can technically be negative. People freak out when they get negatives. X can be negative, but in geometry, when you plug it back in, if I needed to plug it back into something, this would never be negative because it represents a distance. So if I plug it back in, this piece, the mid segment would technically be 10. This one would be 20. So the x value can be negative, but the lengths plugged back in can never be negative. So don't freak out if you get a negative.
It's just like minus 9. Or what do we put?
No, it's, well, this one just says solve for x, so you don't have to plug it back in. So x is just negative 9. So you're working through these and you're going to turn it in when you're done. It looks like a lot. It's not because the first like 8 problems are literally just like cutting something in half or doubling it. So get going. Let me know if you get stuck. That's the only negative. So everything else is like normal. Go. Math. Productive. Got this. I believe in you.